So today we're looking at mostly parallel lines, but we'll look at a little bit of perpendicular as well, and we'll focus more on perpendicular lines in our next lesson. A shortcut for parallel, if we didn't want to write out the whole word, is just two vertical lines. You'll notice that a lot in geometry. Shortcut and perpendicular, there's a couple different ways. Sometimes they just use this. More often, they put a little triangle in there representing that 90-degree angles, because parallel lines go on forever. Perpendicular lines meet in a 90-degree angle. We have two different lines that we're going to graph, and we're just graphing a segment of the line. The line would go on forever. It's a little harder for me to make it go on forever on the iPad here. So -5, -1. I'm going to graph that line and graph the next line, or the next point. And then I'm just going to connect those. And then again, that would represent my first line. My second one is -2, -3. And 10, 3, I know 10 would be all the way to the very end here. And then it's asking what type of lines are formed. They are definitely not perpendicular. They're not meeting in a 90-degree angles. They look like they could be parallel. So I'm going to write parallel. And then we're going to just test it by looking at the slope of our two lines. And we're going to see what happens to parallel lines and what can we know about their slopes. Just a reminder of our slope formula, m equals y2 minus y1 over x2 minus x1. You should pause now and then calculate out your two slopes. And when you come back, those slopes will, I'm going to just do a quick going through those. So line 1, subtracting my y's and then subtracting my x's. And it should be 4 minus a -1. So it's going to end up being 5 over, and I did the same thing on the bottom, 5 minus -5. Just gave what I knew the answer to be, which is 1/2. And then looking at the slopes of our second line is going to be 3 minus -3 over 10 minus -2. And I said 3 and I wrote 6. So I end up with 6 over 12, which is 1/2. So our slopes are the same. Anytime we have parallel lines, they're going to be the exact same slope. If we put them into decimals would be another way to test. They're both 0.5. They both have the same sign, so we can't have one positive and one negative. Everything about them is the same. They would have two different y-intercepts in our graphs if we're looking at the whole equation of the line. You're doing the same thing on part 2, so you're going to go ahead and you're going to work through those. So I'd like you to pause, and then I'll do a quick run through of those. So I'm just putting those first 2 points, and then I'm going to do the slope. And I get -8 over a +6, and I can reduce that to a -4/3. I'm not going to put it in the decimal now. I could if I really wanted to, but at this point it's not a huge deal. Line 2, -7, and -6. And 1, 0. And then looking at those look like perpendicular lines. I'm just going to use the shortcut instead of writing out the word. And I'm just going to test. So 0 minus -6 over 1 minus -7. So this becomes 6/8, which is 3/4. So the first thing I notice is one has a positive slope and one has a negative slope. And this next thing is, it's just flipping that fraction, 4/3 and 3/4. So think about, if you can remember what the word is when we flip the fraction, it's maybe been a while. It begins with an R. It is a reciprocal. So we would say that the slopes are opposites, meaning one positive, one negative. Reciprocals. Okay, and I don't know if that's spelled right. There's a letter there. That's a lovely vowel, but I'm not sure which one it is off the top of my head. So they're opposite and reciprocals. If I, just going to take a quick peek here. We will do more with those next time because we're going to focus a lot more on perpendicular lines next time. This is just kind of your quick overview of those. And then on this one, you're going to be working on this on your own, and I'm not going to go through it. You can always be in one of the meetings and get that, or email if you have questions. You're going to plot all the points, look and see what shape it is, and then looking at the slopes of the sides. Calculating the slopes of the sides, you have the slope formula. You also would always have being able to look at a graph and looking at how far over and how far down it is. It's the same as the slope formula. It's just a different way to look at it. And knowing that if a line is going down, that means that it's a negative slope, and if it's going up, it's a positive slope. So you have a different way to calculate the slope as well. Same thing here. You're kind of looking at calculating all of our slopes, and we're looking to see what do we notice about our shape. What I'm really looking for, do we have any parallel slopes and do we have any perpendicular slopes? So those are two pieces that I'm looking for, or do I have two pairs of parallel slopes? Because that's going to help me out with my different shapes. Now we're going to look at just parallel lines and kind of what do we notice a little bit more about parallel lines. So we said parallel lines are just two lines that never meet. And that means even beyond the graph. Just because they don't touch in our graph, if it looks like they're going to meet, those would not be considered parallel lines. And we said the slopes are the same. So if I'm looking at the two equations that are graphed here, are they the same or not? And one thing I can tell is they both have a slope of 2. I know that's my slope. It's the number that's right before x, or the coefficient of x. They have different y-intercepts, but that just tells me that they're a different point in the graph. Otherwise, they would be the same line if those were the same. And also visually on the graph, I can tell that they're not meeting. So here now I'm giving you an equation of a line, and I want you to come up with a new equation of a line, and I'm giving you a particular point that it passes through. So what I'm going to do is looking at this first equation, the only information I really want from here is the slope. I don't care what the y-intercept is. So this tells me that my slope is 2, my x is 6, and my y is 2. This information is coming from a new point that's on my line. You can use point slope form that we've gone through, or you can use this method. I'm just going to kind of change between the two different methods so that you have a method that you are comfortable with. So 2 equals 2 from the y, because I'm plugging it into y, equals mx plus b. So 2 times 6 plus b. 2 equals 12 plus b. And I'm going to subtract the 12. So negative 10 equals b. So my whole equation, y equals 2x, that's my original slope, minus 10, and that would be my new equation, and that would be parallel to the first line. So I already know the slope, I'm just trying to figure out the y-intercept. Looking at the second one, so if you want to try it on your own, feel free, so just pause, otherwise I'm going to go through it. Same information here. I know that my slope is the 1/2. I don't care about the y-intercept. I have my new point. I'm going to use point slope form here, which is y minus y1 equals m times x minus x1. You do not need to rewrite the formula every time. Y minus 6 equals 1/2, which is also 0.5, so however you choose to keep that. And then I'm going to distribute the 1/2, so y minus 6 equals 1/2 x minus 1, and add 6 to both sides. Y equals 1/2 x plus 5. That would be my new equation of the line. Here you're just doing a couple more problems and seeing whether or not you understand those. And then working on that homework and submitting those into Google Classroom.